Hello everyone, welcome back. So we are going ahead with the multiple regression model, the chapter on multiple regression model, and we are one by one, video by video discussing your different aspects of your multiple regression model. So in line with that, today we'll be talking about your multiple coefficient of determination R square and multiple coefficient of correlation, that is your R. So remember the notation R square. Small r square was used in the simple linear regression model. So for the multiple, we use a capital R square, right? To denote the coefficient of determination. So small r square in your simple linear regression model gave the proportion or percentage of the total variation. Percentage of the total variation in the dependent variable, that is the y variable, explained by the single explanatory variable. So there was a single variable. So uh, whatever percentage of explanation of the variation in the y variable was being explained by the x variable, that was captured by your small r square. In the case of multiple regression model, we have multiple variables. So r square in the case of three variable multiple regression model is the proportion of the variation explained in y by the variable x2 and x3, very important, jointly. So jointly, uh, what proportion of the variation in y is explained by the explanatory variables, that is being captured by the capital R square. So this is the meaning. So I hope this is clear, and you can see the difference here. So in here, the variation is basically due to both the variables. Okay, in here there was a single variable, right? So this is the difference. So the formula is basically your explained sum of square upon total sum of square. We have seen this discussion, so you can go back and see the videos on R square for the simple regression model, right? And you can get an idea how and what these terms are, right? So I've explained these terms in the previous videos, so do go and have a look. So it is given by beta 2 hat summation of small yi, this is small yi, into small x2i plus beta 3 hat summation of small yi into x3i upon summation of small yi square. So this is the formula to calculate the capital R square, and just like my square, small r square, my capital R square also lies between 0 to 1, because my variables can explain the variation in the dependent variable by either 0% or by 100%. So this is the range in which they can move, or the explanation can move, right? No variable can explain 110% variation in a given dependent variable. So the value has to lie between 0 and 1, right? And R, so this is R square. R is basically the measure of degree of association between y and all the explanatory variable. So this is the difference. So this is the measure of degree of association. This is the measure of degree of, or the proportion of explanation in the variation, right? So this is the difference. Just try to remember this. Okay. So relationship between R square and the variance of a particular regression coefficient in the k variable multiple regression model. So variance of, say, the coefficient beta j hat, okay, in the case of k variable regression model is given by sigma square upon summation of small xj square bracket 1 minus 1 upon 1 minus r square j. Okay, so where this beta j hat is the partial regression coefficient. So we have discussed what a partial regression coefficient is. Okay, so the coefficient associated with the particular x variable, so in this case xj, right? That is called the partial regression coefficient of regressor xj, and r square j, so this is important, okay, is the r square in the regression of xj, in the regression of xj on the remaining k minus 2 variables. Okay, of xj. So if you regress xj on the so in the k variable, why is that? Sorry. So in the k variable regression model, there are k minus 1 regressors. Okay, regressors. Okay, so if I regress xj on the remaining regressors or the remaining x variables, so I have k minus 2 regressors remaining. So r square is basically the regression of xj on the remaining k minus 2 regressors. Okay, right? So that is your r square. So that is how you can calculate the variance of the partial coefficient, regression coefficient beta j in a k variable multiple regression model, right? So this is the use of r square, and why r square becomes important, because r square can be used to calculate the variance of my estimators or the partial regression coefficients. Okay, so the chapter is not over yet, so sorry, we still have a few more videos to go in this chapter, so I'll meet you soon with the other videos, and till then, take care.